everyone. Welcome to our deep dive into the fascinating world of how fish eat. My name is Bob.
And my name is Ross.
And together,
We are Bob Ross.
Have you ever wondered how a fish catches its food? Or why one fish might have a huge mouth while another has a tiny one?
Understanding how biological systems work often requires a general knowledge of biomechanics.
Biomechanics isn't just about human movement, though. It's a broadly biological subject. It helps us understand things like why fish swim the way they do, the forces they use, and critically, how they feed.
It's all about the link between structure and function. As the saying goes, structure without function is a corpse, and a function without structure is a ghost. Today, we are focusing on the incredible structures and functions fish use to get their dinner.
This is where the field of function morphology comes in. It studies how the anatomy of an organism relates to what it does.
Adaptations of feeding in fish involve a whole suite of structures used in acquiring and processing food.
Think about jaw, bones, and muscles, teeth, gill rakers, even eye placement, body shape, and how they move. Sometimes even pigmentation or lures are involved.
For many fish, just looking at their jaw shape, teeth, and body can give you a pretty good idea of what and how they eat.
Fish use basic actions like biting, sucking, chewing, and swallowing, but two primary forces are really important: suction and ram feeding.
Let's look at suction first.
Suction feeding is like creating a vacuum. It generates suction forces that can pull items towards the mouth. Many fish can create a pipette mouth, drawing prey in from a distance, sometimes up to half their head length away.
A major evolutionary leap in high teleos, the group that includes most modern fish, is the ability to protrude or thrust forward the upper jaw.
This protrusion helps overtake prey. It extends the mouth around the food faster than the fish's body has to move. It can increase attack velocity by up to 40%.
The jaw movement creates a rapid flow of water into the mouth, with suction velocity increasing incredibly fast, from 0 to potentially 12 meters per second in a fraction of seconds.
Suction feeding typically happens in phases. The fish gets close to the prey, subtly increasing pressure inside its mouth cavity. Then the expansion. This is the rapid part. The mouth opens wide, the jaw protrudes, and internal structures expand, creating maximum suction and negative pressure that pulls water and prey inside. This phase is very short, milliseconds for some fish. Then comes compression. The mouth closes and water is expelled through valved openings at the back of the head, trapping the prey inside. Then the recovery, where everything returns to its resting position.
This whole process relies on an incredibly mobile jaw system, which has evolved significantly in fish. Jaws themselves evolved in fishes, and having a closable jaw for feeding is a key difference between vertebrates and invertebrates.
In ray-finned fishes, as in actinopterygians, the upper jaw initially had a large, fixed bone called the maxilla. Over evolutionary time, the back of the maxilla became freed from the cheek, allowing it to rotate.
Then, in teleos, the maxilla became even more mobile with a flexible joint, and critically, the premaxilla, another bone, became the main tooth-bearing bone and developed an ascending process.
This ascending process allows the premaxilla to be thrust forward with the maxilla acting as a lever. It's a remarkable piece of biological engineering. Suction feeding itself has evolved multiple times across different fish groups, even in some non-teleos like elasmobranchs, sharks, and rays.
While suction is key for many, other fish primarily use ram feeding, where they simply swim directly at their prey.
And then there are specialists whose feeding methods are harder to guess just by looking.
Like lie-in-wait predators that use lures such as a goosefish or frogfish.
Or predators that run down prey, like mackerel or billfishes. Some even use electricity, like electric eels, or have elongated body parts for slashing, like thresher sharks. Even redirecting water flow to jet water is a technique used by triggerfishes.
Beyond the jaw mechanics, a huge predictor of what and how a fish eats is its teeth.
So teeth can come in many forms. Long, slender, sharp teeth for holding slippery fish prey. Think like moray eels or pikes. Numerous small needle-like villiform teeth creating a sandpaper texture, common in elongate predators like needlefishes. Flat-bladed triangular teeth for cutting, seen in barracudas or piranhas, which even have replacement teeth, or sharks have similar teeth, often serrated. Recurved conical teeth for grasping and holding, or molariform teeth, which are flattened and rounded, perfect for crushing hard prey like mollusks.
So, how does this structure relate back to function in specific fish?
Let's revisit those general types. Zooplanktivores often have streamlined bodies, limited teeth, and that protrusible circular mouth we mentioned for capturing tiny prey. Ambush piscivores, fish eaters that wait and lunge, tend to be large, with elongate bodies, sharp numerous teeth, and fins set far back for sudden acceleration.
And remember the specialists, like triggerfish, using water jets.
Or cichlids, they're a great example of adaptation. Their jaw protrusion mechanism is unusual. The suspension and maxilla are mechanically separate.
This decoupling means that they can protrude their jaws in different ways, depending on whether they are eating different types of prey or in different habitats. It's incredible flexibility enabled by a specific structural difference. As you can see, the diversity of fish techniques is astonishing.
It truly reflects the incredible adaptability and evolution of fish structures, especially their jaws and teeth.
By studying biomechanics and functional morphology, we gain a deeper understanding of how these amazing animals have conquered nearly every aquatic environment on Earth.
Thanks for watching.
See you next time.
I'm having a strawberry Pop-Tart.
Yeah.